Hi everybody, in this video we're going to talk about De Morgan's laws. De Morgan's laws tell us what happens when we negate a compound statement, like not P and Q or not P or Q. Let's discover the equivalences by constructing truth tables. We need to start by looking at P and Q. We know that P starts as 1100 and Q is 1010. That's all our combinations we need for two statements. And hopefully by now you're comfortable putting together P or Q. Remember, with OR, you only need one true for P or Q to be true, which means true or true is true, true or false is true, false or true is true, but false or false is false. To get the negation of P or Q, we'll just reverse all of these symbols. So instead of 1110, we'll have 0001. Next, let's bring in P and Q and quickly go over the rule for AND. With AND, we need two truths to be true. So true and true is true, but then true false is false, false true is false, false false is false. Then we'll negate P and Q to change 1000 into 0111. Now that we have our basic statements written out, we want to bring in negations, like not P and not Q. So we'll expand our truth table. Then we'll add in a column for not P or not Q, and then a column for not P and not Q. Not P is the opposite of P, so instead of 1100, we have 0011. Not Q is the opposite of Q, so instead of 1010, we have 0101. Going back to our rule for OR, we know we need one true for not P or not Q to be true. So 00 will be 0, 01 will be 1, 10 will be 1, and finally 11 is 1. When we flip to AND, we're going to need both things to be true. 00 will be 0, 01 will be 0, 10 also 0, but 11 will be 1. Let's just pull out the columns that we need to concentrate on to look at De Morgan's laws. We need not P and Q, we need not P or Q, then we'll look at not P or not Q, as well as not P and not Q. What we're looking for is which truth values are the same, and hopefully you see that not P and Q has the same truth values as not P or not Q. We also can see that not P or Q is the same as not P and not Q, which looks like this. As you look at the statements, I want you to see that when you distribute the negation, you switch the operator. Once we know De Morgan's laws, we can apply them to statements and we can use them to show that things are equivalent. Let's look at a few examples to see how De Morgan's laws help us negate compound statements. We'll start with the statement, the report will be late or the deadline is extended. When I put in the negation, I know I'm going to have to put in negation for the first statement and the second statement, and I'm going to flip the OR to an AND. I'll have the report will not be late and the deadline is not extended. Let's try that again. This time we have the kitchen is closed and you cannot put in a takeout order. In this example, when I negate cannot, I have a double negation. I don't want to say you cannot put in a takeout order. So when I negate this statement, I'll say the kitchen is not closed and switches to OR, and I'll say you can put in a takeout order. Really be careful with these double negations so your statement is clear. Let's do one more. This time I have the system update did not install successfully or the computer did not restart. This statement starts with two negations and an OR connector. We're going to take out those two negations, we'll switch the OR to AND. So our negation says the system update installed successfully and the computer restarted. Now that you've seen De Morgan's laws and truth tables and practiced a few examples, you can use them correctly to negate compound statements.